You can compare the strength of the cylinder with what has been specified for the project, and if the specified strength of concrete for the project is equal to the strength of the cylinder that you have determined in the lab, then it says that concrete passes the criteria. However, if the cylinder strength is less than the specified strength which has been specified for the concrete in the project, then we will say that concrete has failed. Concrete has failed and it has not achieved its compressive strength. So in this manner, you can check the quality of concrete at a site. Okay, you know that I hope you would have already conducted or done a test on a concrete cylinder. If not, you can do this very easily. Every day we receive tens of samples in our concrete lab. You can go to the concrete lab, material testing lab, and you can ask the in charge of the lab about the testing of cylinders. So they will give you a proper time where they will be testing cylinders. So you can watch this testing of cylinders. Okay, I can also show you a video of a testing of a cylinder. The ASTM standard C31 and C39, they cover this testing, because you know that testing cannot be done arbitrarily or to the choice of a person. Testing must be done according to some protocols. And these protocols are given by the ASTM, American Society of Testing Material Standards. You must have to test your sample according to the ASTM criteria. Okay. This is a stress strain curve, a typical stress strain curve for a cylinder. You can draw a typical stress strain curve for a cylinder. Okay. When the load is applied on the cylinder, then the stress is load divided by the this circular area, pi by 4d square. So load divided by this area will give you stress, and the strain. If you are able to measure the deformation of the cylinder, then the change in deformation divided by the total length of the cylinder will give you strains. You can plot the stress versus strain on a graph paper like this. Okay, you can see this is a typical stress strain curve for a cylinder having a strength of 4500 psi. If you look at this curve on the left, in the blue line, basically the peak of the blue line is at a value of 4500 psi, and the strain corresponds to this is around 0.0022 or something like this. Okay, so the concrete peak is at a strain of 0.002 or near to 0.002, and the strength is 4500 psi. And the final downward branch of this curve ends at a strain value of 0.003. Okay. You can also see the different curves on the right now in magnified view of this. These are different curves for 2,300, 3,000, 4,000, 5,000, 7,000, 8,000 psi concrete, and there is a peak of this, and then there is a downward branch of this curve for every cylinder. And you can see that invariably the strains are from 0.002 to 0.003 to 0.004. So they are the ranges of strains from 0.0025 basically to 0.004. These are the strain values, and the strength varies depending on the constituents of the concrete, because generally with the increase in cement content, the strength will increase. But there are many things which must be kept in mind while designing, while proportioning the concrete constituents for a high strength concrete. Okay, next I will show you a video which is a test on a concrete cylinder. The stress strain curve and the test of the cylinder both are shown side by side. The cylinder age is 4 days. The concrete age is 4 days. So you can see 4 days early age concrete. You can also see that in the beginning, the strength and strain are linearly proportional, because it is a straight line. So in the beginning, the stress is linearly proportional to strain. But with further increase in load, then the linear relationship ends in a non-linear relationship in the form of a curve is shown. So up to around 50% of the strength of concrete, the relationship is linear. But after that, the relationship becomes non-linear. You can see the final value of strain is 0.0024, and the strength is around 2700 psi. Okay. Okay, we were talking about the compressive strength. Now talking about the tensile strength. Although tensile strength is not usually required to be determined in a reinforced concrete structures, there are some situations in which tensile strength needs to be known to us or determined. So it is better to know what ASTM standard governs this standard test. ASTM C293 basically covers the tensile strength of concrete, and this is called a standard test method for flexure strength of concrete using simple beam with center point loading. The beam is 6 by 6 inch in size, 6 inch wide, 6 inch deep, and 30 inch long, and it is subjected to a point load in the lab. You can do this test very easily. If you are interested, you can come to the lab, talk to the lab in charge, prepare a simple 6 by 6 inch and 30 inch long, and test it in the lab, and you can determine the tensile strength of concrete by the equation shown below the beam figure. Okay, this is Fr is equal to 6m divided by BH square. M is the bending moment at the center point, because if there is a point load on the center, so the maximum bending moment will occur also at this location. So maximum bending moment can be calculated, because when you test the sample, and mind that this is made of paver concrete, not reinforced concrete, paver concrete, only concrete without reinforcing bar. So when you test this, you can determine the load P, and from the load P you can calculate bending moment, because in a simply supported beam subjected to a point load, M will be equal to P L by 2. So the bending moment can be very easily calculated, P L by 4, and BH square are the dimension of the beam. So Fr is equal to 6m BH square can be calculated. This Fr is basically the maximum flexural tensile strength of concrete, determined through this test. And this maximum flexural tensile strength is also called as modulus of rupture. Modulus means measure, and rupture means failure. So this will be the measure of failure of a pure concrete beam, only concrete, no reinforcing bars. Generally speaking, the tensile strength of concrete is 8 to 15% of its compressive strength. Okay, if you have a chance to plot for same concrete, its tensile strength against its compressive strength on x-axis and y-axis, so you will see that there is no direct relationship between the compressive and tensile strength. But if you take square root of Fc prime, the compressive strength, then you will have a very good relationship between the tensile strength and the square root of compressive strength. This is a practice which is usually done in research, in research by researchers. If you want to make a relationship between two variables, sometimes direct relationship between the variable is not possible. For example, if you want to plot, if you want to test concrete from same sample or from same concrete, if you prepare cylinder of concrete and you prepare beams of concrete,